I'm audible, I guess. Hello, everyone. I'm Adam. Thank you for a nice introduction. So I'm from Aleph0, where we're working on a product called Liminal, which is going to be a privacy framework for transactions and smart contracts. And today I'm going to present a pretty broad overview of transaction privacy versus compliance, the hot dilemma which is recently discussed. So the first and biggest problem in blockchain privacy is that it doesn't exist, basically. I mean, if you don't use any sort of privacy solution, every transaction and everything that you do on blockchain is visible to basically everyone, which means that everyone can see how much you're spending, how much you're earning. It's definitely not how we would imagine financial systems to work. There is also a second problem, which is that we do have privacy solutions already, although they are pretty often used for illicit transactions. So as a popular example or famous example is Tornado Cash, which in the last year was used to launder at least $600 million by Korean government. And in the aftermath, it was sanctioned by OFAC, Office for Foreign Assets, something, I don't remember, sorry. I'm not a lawyer by training. So it affected not only Korean government, which obviously it should, but it affected a lot of normal users, because a lot of regular users were using Tornado Cash just to anonymize their funds. And right now, all Tornado Cash addresses are on the sanctioned list, so it's very hard to get the funds out of it. OFAC provides some guidance to that, but definitely there is a lot of trouble for anyone who just wanted to be anonymous on blockchain. So we kind of have two types of adversaries in this story. So the first adversary, these are observers. So these are basically people who would like to peek into your transactions. And they can do it for various reasons. There can be corporations which want to basically data mine financial data for their profit. There can be just your neighbors or whatever wanted to peek into your transactions. So why do we want to counter them? Well, because they basically violate the basic rights of every user on the platform. And the second type of adversary are fugitives. So these are the actual criminals. These are the actors which are trying to hide funds coming from obviously illicit sources. So these are, for example, bridge/exchange hacker. Lately, it's mostly bridges that has been hacked for enormous amount of money. So what do we want to counter them? So first thing, they are evil. And the second thing is that a lot of people and organizations are after them. So if we do not counter them on the protocol level, chances are that the protocol will be in some way at least banned, and that will affect regular users, as it happened in the case of Tornado Cash. So the main question is, can we actually counter money laundering by these obvious adversaries while still keeping users in control over their financial data? So without introducing mechanism in which someone would be able to peek into our data without our knowledge and consent. So our goal is to have it in such a paradigm that there always will be a consent from a user to reveal the data. So first, let's provide some background. What's a privacy system? So this is a basic picture of a privacy system. And so basically, it doesn't operate in a vacuum, almost never. So you can get some funds into the privacy system, you can get some funds out of it. And the question is, what happens inside? So there are basically three basic types of such systems. The first, the most basic, is a mixer, where what happens inside? Nothing happens inside. Basically, the only thing users can do is put some money into the privacy system and get them out. Interestingly, this is already enough to anonymize them. So, for example, in this picture on the left, no one will know who D is. So there have been 3 users putting 1 ether into the privacy system, into the mixer, 1 user getting them out. It could be any of them, basically, even though nothing happened inside. So the only action which is allowed is putting something inside and outside, and that's already enough to break the financial trace. So then the next level are transaction systems, like Zcash. So then inside there are accounts inside, and users are allowed to transact among themselves and among the accounts inside of the violet rectangle. And yet next stage are private smart contract platforms like Liminal, which we're building, where inside of the rectangle users are able to arbitrarily interact with smart contracts. I'm not going to go deeper into what does it mean to interact with a private smart contract, but in general, it's a generalization of a transaction system to some extent, at least. So what can be done here? How can we improve users' privacy? How can we provide such a system in a way that it's not going to be like a paradise for North Korea? So we need to provide a way of revealing a trace to chosen parties. So we can be allowed to use a private privacy system, but whenever asked for it, it would be good to have a convenient in-protocol way of revealing what is our source of funds, or at least that it's not illicit. So going through these 3 categories, when it comes to trace recovery, mixers are actually pretty simple. So there is a concept of viewing key, which is almost as old as Zcash. And it's a key which is derived from the private key of the user, and it allows to share transaction visibility with any party. So this is the scheme of how Mixer operates. So as we've seen before, basically what the public sees is only that there are 4 actors putting something into the mixer and 4 actors getting it out. Although it mixes, right? So it's very hard to connect the ingoing and outgoing transfers. What actually happens is that there are kind of accounts inside. So users actually put funds on the private account, and then they are allowed to get out of the private account. And what can be seen with viewing key of actor B is, well, as we could expect, this is exactly what actor B have done. So with the viewing key, any party having the viewing key could actually unmix the mixing thing for this particular user. So why does it help? So a big problem with Tornado Cash and solutions like that is that eventually we want to do something with these funds. For example, we want to send it to the exchange, and then we want to be able to answer the question, well, where are these funds coming from? So if such a question occurs, using this kind of solution, which was, by the way, not implemented in Tornado Cash, we could just provide the viewing key to any such party and reveal that, well, this source of fund was not illicit, it's not related to any bridge hack, it was just related to, well, some other Ethereum address which looked like legit. So revealing for just one party sex is definitely better than having everything super public on the blockchain for everyone. Although it violates some privacy. So on the diagram of things, like where we can either counter observers or counter fugitives, we would be definitely better at countering fugitives with viewing keys based mixers. We are perhaps a bit worse at countering observers because we are allowing checks to observe our financial trace. Next, trace recovery in transaction systems. This is a significantly harder problem. So here, let's see on the diagram. Let's say that there has been some next hack by North Korea. They stole some money, some funds from the bridge, let's say, and they get into the privacy transaction system. So what can they do? Is they can send it to one account. Then inside of such a system, they can make a private transaction to the other account, and then they can get the funds out from the other account. And they will be happy about it. So why they will be happy? Because then they can reveal the viewing key to the other account and say that, well, yeah, so this is our viewing key. As you can see, we got these funds from some other address in our privacy system. Nothing, I mean, no red flags should show up because, well, it's not connected to the hack that we all know about. So, I mean, and providing this kind of a viewing key, it's not obvious that they have any more information. So CEX or any other party cannot ask or cannot demand additional information because it's not obvious that this account also is theirs. So basically, with this kind of weak trace recovery, it's pretty hard to prove that the funds are not coming from this obviously illicit sources. So does it mean that Zcash and like are kind of not compliant? No, it doesn't mean so. What it means is that in some situations, users of these platforms can be asked to provide out of protocols proof of source of funds. So this can be inconvenient. This can be actually hard to organize. So what we would like to do is to provide a protocol which would allow creating such proofs in a simple and convenient way for users. And the third say, type of the privacy system is this general privacy system with smart contracts. So let's focus on DeFi, or how the DeFi looks like. So how the DeFi looks is that usually user would put some funds onto the private account, and then basically entire DeFi that we know right now is based on users interacting with smart contracts in a way where users are sending some tokens to smart contracts and receiving back some other types of tokens for the same account. So this is how decentralized exchanges obviously works. But this is also how liquidity provision works. I mean, we put some tokens to some pool, and we get so-called LP tokens, which represent the rights to getting out our tokens. This is how lending protocols work. We put some tokens, and we lend some tokens in return, which goes to the same account. So from the perspective of trace recovery, actually this is pretty simple, because there is only a single account which is involved here, and it makes some calls to the smart contracts which are sending the funds back. So it's impossible to do this dirty trick that we've seen on the last slide. I mean, there cannot be, if we would have a system which basically implements only DeFi without between user transactions, then the recovery of trace would be significantly simpler. Actually, as simple as in the case of regular mixers. So we could implement viewing keys, and let's say this is what actually happens, that there are some users interacting with contracts, and the viewing key of A, we could basically trace where the funds are coming from. So the funds could come from here, from account A, and then came out at the account A prim. So that would provide a link between these funds. This is what basically would be needed to prove that they're not coming from the illicit source. By the way, this is also interesting because the amount of funds here can change. I mean, people do DeFi because they want to earn API. So basically, in these smart contracts, something happened. This could be potentially different types of tokens, but it doesn't matter for this purpose. The only thing that matters is that these funds, like perhaps in the form of different tokens, are coming from account A outside of the system. So it seems like from all of these things, there is only one hard problem, which is between user transactions. Which cannot be easily solved by viewing keys. I mean, it's very hard to provide a scheme with just viewing keys that would allow for convenience trace recovery. What can we do, though, is something a bit different. So there is a cryptographic primitive called ZK. It's a generalization of Zcash protocol, of original public transaction, private transaction protocol. And it does a lot of great things. I mean, it's a very vast generalization. But among them, it allows to define arbitrary conditions that are required for the transfer to succeed. So, for example, like a simple example would be that in the system, transfers of above 1,000 tokens are disallowed. So this is a potential condition one could like to implement. So then if a transaction would be for a higher amount than 1,000 tokens, it would be automatically discarded. Basically, when doing transaction, then user needs to provide a proof that the condition is satisfied, and if the proof check doesn't pass, the transaction is, as I said, discarded. The more interesting rule to check would be that transactions don't originate in any of the blacklisted addresses. So this is the rule, of course, which would have to be changed with time. So the concept of a blacklist is that there is some possibility of adding addresses to this list. But actually, it conveniently solves our problem in a way. So come back to the example of North Korea. Let's say that they hack this another bridge and would like to launder the money through this system. So okay, they transact, they put money into the system. Then, well, this is actually, I think, necessary step because the hacks are usually not discovered immediately. So we need some delay here. So let's say the system has implemented 24 hours wait for deposit exceeding some amount. Let's say $5 million. Like these hacks we've been talking about from Korea are anyway in the amounts of hundreds usually. So there is this wait for acceptance. And during this wait, the hack is discovered, and the DAO governing the blacklist decides to blacklist all transactions originating from deposit S, because this deposit S, this is from outside of the private system. So, like everyone can see that they are coming, for example, from Ethereum address that is directly involved in the bridge hack. So, once it's discovered, this origin is added to the blacklist. And effectively, like any transfer from this account from then on is discarded, and funds are effectively locked forever, or at least until the address is removed from the blacklist. So it seems to solve the problem. It creates another problem, which is that it requires some authority or DAO or some singular group to globally decide on a single blacklist. Which is problematic for many reasons. Like one of obvious reasons is that there are multiple jurisdictions in the world, and there are some things which are banned in one of them and not banned in the other. And of course, there can be a lot of government pressure to blacklist addresses related to some, let's say, actors not liked by some particular government. So what can be proposed instead is to have multiple such authorities and let users choose which they would like to use. This is also better in a way that it gives much more power to the users. So how would it work this is a very rough idea of like user experience of such a platform. So let's say there are multiple blacklisting instances. Anyone basically could create the blacklisting instance. And then user can subscribe to any number of such instances. And then whenever user wants to, let's say, interact with a centralized exchange or any other party that requires the proof that the source of funds is okay, then the user can provide the proof to which blacklist the user is subscribed. So let's say that I want to transact with some big exchange, and I provide a proof that, of course, I'm subscribing to OFAC sanctioned blacklist and some other blacklist that is also universally accepted. And well, I don't even need to provide the trace of my funds. I'm providing the proof that my funds are not originating in any of the addresses or any of the sources which are universally, say, acclaimed as illicit. So. Yeah, this is the pretty rough design, more about the user experience, but this is something that is generally possible to achieve by ZK in a way that it's possible to provide arbitrary conditions for the transfers to pass. So we can do it per account, and then, as I said, the selective reveal of the entire trace is not even necessary. So at the end, the disclaimer. So none of this information constitutes legal advice. I'm not a lawyer by training. This is more like a technical overview of the capabilities of such systems. And we do work on the liminal, and this is our general vision, although it should not be seen as a specific roadmap. Things here are still subject to changes. Thank you for listening. So if anyone has questions, I'd be super happy to answer them. I think there is a question over there.
Hi. I'm super newbie in this. I am developer, but not in this area. And I have a new project which works with smart contracts for automotive industry in Switzerland. Maybe you know the company AMAG. So they are trying to enter this area of having a leasing contracts as a smart contracts. Can you tell us, maybe there are somebody else like me that don't know how that works, in a sense, where are these capabilities? What are these smart contracts? Where are they going in the future with this technology?
So you're asking about privacy in smart contracts specifically, or?
Maybe general then.
So, well, I think there's like a lot of general research on smart contracts. One, for example, of interesting paths not related to privacy is parallelization of smart contracts. So there are projects like Aptos and Solana to some extent as well. But when it comes to privacy, there are basically two paradigms which are used right now in making smart contracts private. The first is the aforementioned ZK. This is in the scope of the presentation, I showed how it could roughly be used for the compliant purposes. Actually, it's much more general, and it's a framework where arbitrary computation on the user-owned private data could be performed. Although this is a pretty tricky paradigm of programming, and it's by far not the way that you can just take, I don't know, Solidity smart contract and kind of magically transform it to ZK. It's not only the question of programming language, it's a question of the paradigm of who owns which data. So I think it's gonna take some time until we see a broad movement towards this thing, because it's pretty complex. So right now what we're focusing on is rather providing convenient small pieces of code which computes in private, so you can just take it and use it instead of learning all these complex frameworks. And the other paradigm is called multi-party computation. And it's used in the situations where you would like to have a private state which is not assigned to a specific user. So this is basically how DeFi operates, that Uniswap has its own private state which is not assigned to any specific user. It should be private and no one should know what's there if we want to have private Uniswap. So multi-party computation is basically the primitive which would allow this kind of very general private smart contracts, where smart contracts can be fully autonomous and still has its own secrets. Again, Ver.
Hello, Adam. Thank you for the presentation. I would like to ask one thing that regards to the Tornado Cash compliance tab. So there is a specific tab on the Tornado Cash app in which you can actually input the note that you have received from Tornado Cash after you put it in the mixer, which actually reveals the previous deposit, which you can use for any compliance purposes that you could have in the future. So the question is, how does it differentiate with what Liminal is doing, and is it even a comparable thing?
So how it differentiates from the general view in key is, as far as I know, you can do it per transfer, you cannot do it per account. Like what's implemented in Zcash, for example, is that you can use singular account if you want ease of use for this revealing purposes, and then you can provide just singular key for any party, and then the party can see all the transfers, and the party will be convinced that there is nothing more. Like that's all. That's all you've been doing on this account. So in Tornado Cash, it's not like that. And how it differs from what we do is, well, we are doing much more than just a mixer. So there are multiple problems with Tornado Cash. Like one of them is that, for example, it was hard to compose other products with it because it operated only on specific amounts of Ether. I mean, there was a project called Tornado Cash Nova, which was, I don't know if you're aware of it. So basically, it was a generalization of Tornado Cash, which was designed to operate on not only on specific amounts like 0.01, 0.1, and 1 Ether, but you could put any amount of Ether inside. Although, unfortunately, I mean, I don't know. Anyway, it was banned together with the original one, and I think it didn't even make to the Ethereum mainnet. But what we are planning to do is having this notion of a private smart contract, which is definitely not something Tornado Cash considered. So we want to have this privacy field to expand even further than just mixing funds that have been used in a public way.
Yeah, one last question.
Hi, Adam. So my question is more of a general one. What is the greatest obstacle that you're trying to conquer, which is the most complex and time-consuming?
So definitely a big obstacle is performance. So like all this cryptography that's behind private computation is slow. Like there are two cryptographic paradigms, ZK-SNARKs basically and MPC, and both of them are terribly slow. So when it comes, so they differ in this regard. So ZK-SNARK is something that user computes on personal machine. So it's slow, but it parallelizes pretty well. So in the sense that if there would be like 1,000 users, so even if a transaction requires 10 seconds of computation from each of them, then still 1,000 transactions is still 10 seconds, but like on machines of each of these users. And multi-party computations is also slow, but it's worse in the way that needs to be computed by the blockchain. So like when you have 1,000 users, then they need to be computed sequentially. So definitely the biggest obstacle is performance right now. So we have this design where under MPC we are planning to compute only the very, very small and specific computations, and the rest offload to SNARKs. And well, SNARKs are, I guess, in cryptography, one of the hottest fields. So we are seeing new results every month, basically. Right now, regular transactions, the faster system I've seen is 2 seconds of approval time. So it's 2 seconds of computation of computations on the user machine, which is already pretty good. The problem is that if we want to have this compliant, we need to run these additional checks. So that definitely will add some time to this 2 seconds. So yeah, definitely there's a big race here to make it make the user experience so that it's like almost seamless with computation, which is on the machine.